Hello again. We are moving on to talk about the concept of expectation, and that's basically what we can expect to happen using theoretical probability once an experiment is actually carried out. So that's lesson 6.7, and we will get started. How do we calculate expectation? Well, basically we have a trial that's conducted a certain number of times. The probability of being successful is p, that's a fraction somewhere between 0 and 1. And so the number of times we can expect to be successful is just those two things multiplied together, n times p. So for example, if I wanted to see how many times I could roll a 4, well, the probability of rolling a 4 is 1 out of 6. So if I roll the die 30 times, then I multiply those two things together. 1/6 times 30 would be 5, so I can expect to roll a 4 5 times out of those 30 times. So that's how it's calculated. Expected value, let's say I spin this spinner on the right, and I'm either going to win or lose the amount that I land on. So if I land in the I guess reddish orange, I'm going to get $8. If I land in the more yellowish orange, that's going to make me lose $5. If I land in the green, I'm going to get $6, and if I land in the light blue section, I'm going to lose $2. So about how much on an average spin can I expect to win or lose? So what I do is it's broken up into uneven sections. So I need to take each section of the circle as the probability of the spinner landing in that area and multiply that by the dollar amount that's associated with that area. So the blue part, that is 1/8 of the circle, and I would lose $2 if I landed there. So those two multiplied together is negative 50 cents. The green section is also 1/8 of the circle, and if I land there, I gain $6. So those two multiplied together give me 75 cents plus. If the yellow section is 1/4 of the circle, and if I land there, I lose $5. Multiply those, and I get negative $1.25. And then finally, the orange is 1/2 of the circle, and if I land there, I gain $8, so multiply those together, and that's $4. So if I add all of that up, I get a total of $3. So if I keep spinning and spinning and spinning and gaining money and losing money and gaining money and losing money, on average with each spin, I gain $3. So that's how expected value works. So the formula for expected value looks like this. I've got a bunch of outcomes, and this is what I just did. Had a bunch of outcomes, x1, x2, x3, and so forth, and they've got probabilities. So the expected value is just going to be each of those values for each outcome multiplied by the probability associated with it, and you add it all up. Okay, or that funky sigma symbol of each x times each p, and that sigma symbol means that you add all of those products up. Okay, now let's talk about fair games. We need to cover this concept because sometimes you may be asked, is the game fair? And so here's how you calculate whether the game is fair or not. Let's say the $3 from that game that I talked about earlier, that's my expected gain. Okay? So games can only be considered fair if the expected gain is 0. So obviously that first example was not a fair game because I win more than I would expect to lose. So a game is fair if you can expect to, on average, gain 0, so break even after playing it a bunch of times. That would be considered a fair game. So if you have any questions about this, please let me know, and I will see you tomorrow.